Imagine a small city car. It weighs about 1 ton. If you drive it at 200 miles per hour, what happens? Nothing. It stays firmly glued to the pavement. It might shake, it might roar, but it's not going anywhere but forward. Now, look at this giant of the skies. A fully loaded long-haul jet. It weighs 400 tons. That is the weight of 80 African elephants or a fleet of 400 cars. Yet, the moment it reaches that same speed, it lifts off with the grace of a bird. Why does a car stay grounded while a metal skyscraper with wings defies gravity? It's not magic. It's a beautiful battle of physics. Everything starts with a very specific shape, the airfoil. If you look at a wing from the side, it's curved on top and flatter on the bottom. Think of the air as a massive crowd of tiny invisible people. When the wing slices through them, the crowd splits. The air traveling over the curved top has a trickier path than the air sliding underneath. Because of this shape, the air on top has to move faster. And here is where it gets crazy. According to Bernoulli's principle, fast-moving air creates lower pressure. Basically, the air on top is stretching out, creating a vacuum effect that sucks the wing upward, while the slower air underneath pushes it from below. This force is what we call lift. But lift alone isn't enough to carry 80 elephants. We need a massive kickstart. To get that air moving fast enough over the wings, you need incredible speed. Enter the jet engines. These aren't just motors, they are professional air swallowers. A single large jet engine can suck in 50 tons of air every second. Imagine inhaling the entire volume of a basketball court in the blink of an eye. The engine compresses that air, mixes it with fuel, ignites it, and blasts it out the back at supersonic speeds. This follows Newton's third law. For every action, there is an equal and opposite reaction. By throwing a massive amount of air backward, the engine pushes the plane forward with titanic force. This is thrust. Without thrust, there is no speed. Without speed, there is no lift. And without lift, well, you just have a very expensive, very heavy bus sitting on the runway. Once the plane is in the sky, it is caught in a permanent tug-of-war between 4 invisible giants. Weight is constantly trying to pull the plane back to Earth. Lift is fighting to pull it into space. Thrust pushes it forward. And drag, the friction of the air, is trying to hold it back. To take off, the pilot does something crucial. They increase the angle of attack by lifting the nose. This forces the air to hit the bottom of the wing even harder. Think of putting your hand out of a car window and tilting it up, your hand jumps. At this exact moment, lift becomes stronger than weight. The 400 tons of metal suddenly feel weightless to the air. The ground lets go, and the plane climbs. So, the next time you're sitting in a window seat, look at that wing. It's not just a piece of metal. It's a precision tool cutting through the atmosphere, using speed to turn the air into a solid staircase. If you enjoyed this flight through physics, make sure to hit that like button. It helps the channel more than you know. And don't forget to subscribe so you don't miss our next episode, where we'll explain how pilots managed to stop these 400-ton beasts on a rainy runway without melting the tires. Quick question for the comments. Where do you think is the smoothest place to sit in a plane during turbulence? The front, the middle, or the back? I'll be reading your theories. See you in the next one.